Hello. The first problem, we have a guest here today. I know that this might be a distraction. Who told me that today? Katie, you know who you are. Tom, the HVAC guy, is here today. Very important person in your life. He keeps the classroom the perfect temperature. Now, next year, many of you know by now that I'll be working in Abu Dhabi. Well, Abu Dhabi is in the United Arab Emirates. And south of Abu Dhabi is a city, an emirate called Dubai. And in Dubai, there is a now very famous building called the Burj Dubai, or the Burj Khalifa, same building. Burj Dubai, Burj Khalifa. The reason it's so famous is because it's a half a mile tall. The World Trade Center is a quarter mile tall. The Burj Khalifa is a half a mile tall. Pretty intense. This problem, exercise 11. The Burj Dubai in the United Arab Emirates is the tallest building in the world, dwarfing such structures as the Sears Tower, which is in Chicago, and the Empire State Building in New York City. How much pressure is needed in ground-based water pipes? How much pressure is needed in ground-based water pipes to pump water up to an apartment in the Burj Dubai 500 meters above the ground? The Burj Dubai in the United Arab Emirates is the tallest building in the world, dwarfing such structures as the Sears Tower and the Empire State Building. How much pressure is needed in ground-based water pipes to pump water up to an apartment in the Burj Dubai 500 meters off the ground? Okay, now, let's review a few points here when we do this. The Burj Dubai is very tall. We're not even worrying about the entire height of the building. We just want to talk about 500 meters. So 5/8 of the way up the building. So the height is going to be 500 meters. Now, you recall in exercise 10 that the pressure of a fluid, Thomas, thank you very much.
Okay.
You're scholar and gentleman, in whatever order you prefer.
All right.
Excellent. The pressure of a fluid is going to be based on the height of the column, the density of the fluid, and G. So let's write that down. So it's going to be based on, let's pick out another color here. It's going to be based on the density. We have it here, density, G, and H. Now, what is this additional aspect? Well, P, pressure, sub H, is hydrostatic pressure. Hydrostatic pressure. Hydrostatic pressure is the pressure from the fluid column, the water, plus the atmospheric pressure. So not only is it under pressure to pump the water up 500 meters up the building, but it also has the atmospheric pressure on top of it too. P sub A is atmospheric pressure. P sub A, not PA. PA is pascals. P sub A is atmospheric pressure, plus that's the pressure of the fluid is going to equal the hydrostatic pressure. The sub A is atmospheric pressure on Earth, the atmospheric pressure on the surface of the Earth at sea level on the ground is 101,000 pascals, 101,000 pascals. Remember that a pascal is a Newton per meter squared, a Newton per meter squared, or a PA, a pascal. So, Burj Dubai or Burj Khalifa, 800 meters tall, but we only care about 500 meters. That's the equation. That's the atmospheric pressure, the air pressure. These are the unit labels for pressure. Don't confuse that PA with P sub A. And I want you to solve for the hydrostatic pressure to get water down that's on water to force it up 500 meters up a building. Now remember, students have been telling me that they just watched the video. If you don't have a pencil and paper and a calculator and are doing the calculation before I show part 2, you're wasting your time. You've got to do this along with me. Be right back.